Okay, awesome. So the homework is pretty straightforward. I won't re-explain it. I'll just have to let the other folks suffer. Any questions about this homework? It's going to be something like this. Now, it would be really awesome if you came up with a class that would be useful uh, in your work, if it's possible. Might be a little early for that, but maybe not. You want to think in terms of what is an object. You want to think in terms of I'm going to create objects where I could create multiple objects. Not necessarily the case. Remember, we've been dealing with different generated objects all the time, like a file handle, for example. The handle that you get back from the call to open, when you say open a file and you get back this file handle, and then you say file handle dot readlines, right? That's a constructed object with methods. And you may only create one of them. You don't need to create multiple ones, although you can, right? We create one that does that, right? Maybe you'd like to create, imagine this, create an object that opens up a file, and when it returns the lines of the file, it prepends a line number to every line. Or imagine a object that opens, when you instantiate the object, you instantiate it with the name of a file, and it opens up the file and it returns, instead of a list of lines, it returns a list of lists split on a particular character. So it does the splitting for you. But imagine that it's far more sophisticated than that. You were talking earlier about opening up text files and discarding the header, right? Now that's a repetitive operation, but now this may just be the kernel of something that would do a lot more than what you want. But let's say you had a class that the object is aware of the type of file it's working with. So it knows it's a comma separated values file. It knows it has a header that it wants to discard, right? And so when you instantiate the object, it opens the file, discards the header, and places all the lines into a list for you. Or maybe even goes further, creates a matrix, a list of lists, right? So that all you have to do is just instantiate the object with the file name, and all of a sudden you've got a list of lists with everything you want. All the work was done for you. You didn't have to call any methods at all. It just all got done. Now, what's super convenient about that is that you set that up as a class once, and then you never need to think about it again. All you need to do is remember the name of the class and instantiate the object, and it works just like a file. Everything's great. Or it works like a file, maybe it doesn't work like a file, it works like a list of lists, or whatever you'd like. You could have the class make use of the CSV module and do all the right things, things you want it to do, whatever it is. So classes can be super, and then also, they talk about complexity. Sometimes there are people that have said in the past, if your program's getting more complex than you'd like, just make more objects. They say it shouldn't be a substitute for well thought out design. But sometimes when you write, I don't know, you've written code without a plan. I'm sure you've done it a million times. I've done it a million times too. You just start with a general idea of how you want it to work, and you start writing sections of the code. And then maybe later on you're like, it's getting a little complex. I don't know exactly what I'm doing now. It can work well if you just create objects that do specific things and then call those objects. For instance, in your homework system. I didn't have to do this, but I thought it'd be an interesting experiment. In your homework system, there's different types of sort of objects to think about. There's a student object. There's I called it a weeks object, which knows about all the weeks from the class, like what the dates of the weeks are. There are a number of different objects that I created, and then I just call methods on those objects. In other words, instead of having to remember all the different function names, I just look at the documentation for each object, and I'll say, employee.getAssignment and put the assignment number, and it gets the assignment for me. Without me having to think about, again, what's the data source, where do I find the thing, what's the name of the file. I just encapsulated all of that into a particular class that knows what it's about. I just say new student, and then your student ID, and then I'll say student.getAssignment, and the name and the number of the assignment. It works exceedingly well for organization. It's really great. And then anytime I want to make a change to the way let's say the assignment is gotten, maybe I want to shift over to a database, I just change that class code. So anyway, so here's your assignment. And maybe, I don't know, maybe we should do another one, besides this one. Maybe this one's too easy. Maybe something's uh, a little more practical. Okay, with 40 minutes left, let's see what else we can talk about. Any questions? Pretty straightforward.
The projects that you offered for the web and for the web scraping, where can we upload them?
Well, they would take the place, I guess, of the web assignment that I had. You had either 7.1 or 7.2. But if you wanted to do additional ones, you could email them to me. Or you can paste them in the same window, and then I could comment on them. Yeah. Say? The other web projects?
Yeah.
You're asking whether what? I'm sorry.
Yeah, I'm just asking. I saw there like appended about web projects. Say just pick one. Is it also to be submitted? Is it last to be submitted?
You can submit any one of them. You could just pick one. Is that what you're asking? You just arbitrarily pick one of them?
Yeah.
I didn't quite answer the question, I know. But okay, you can ask me later too. Any other questions about the web projects? Yeah.
One of the homeworks was to get ticker with the price in euros and stuff.
Right.
Or write a class to get
Yes.
exchange rate.
Right. Right. The object of the class might know what currency to use. Yes. So you'd say var equals get ticker euros in the argument. Yeah. And it would just know that data. Sure. Yeah, that would work. Convert one of your web projects into a class-based thing. And as you write longer and longer programs, you're going to want to start working with classes. It makes everything simpler. And this whole admonishment, this idea of just make more objects is kind of interesting because it's basically, it's not saying, chart your design, make a diagram, make it more clear. It's just saying, create more objects that do. And then a lot of classes that you see will be very small. They do very small things, A lot of web design is designed like making very small chunks that call each other, trying to handle that complexity. I once, during the internet boom, and I was trying to get my first programming job, and I knew some Java, and I mentioned I didn't drool. I had a bunch of recruiters who were all over me because I was, whatever, young and bright and whatever. I didn't have any really particular, background. I just had this Java class, but the recruiters were all over me because that's what the environment was like. And I actually accepted a job, but I still had an interview left, and I was just curious, so I went in to the interview anyway. I was kind of wasting the guy's time, and I felt kind of bad afterwards, because actually by the end he could tell I didn't want the job. He was actually smart enough to understand. He's like, do you really want this job? He actually confronted me with that, which then made me feel really bad, because he found me out. But he was designing a financial system in Java, but he didn't want to write all the code. He wanted to hire code monkeys, basically, to take his design. So he said, this is what I'll give you. And he gave me like 5 or 6 pages that he had written saying, this is what the class needs to do. And so he was designing it by designing all what the classes should do. And then he was, I guess, writing the overall code that called all the classes so you could test it later on. But it was all written in small units, and each one was a class. And so he just said the class should have this method, and this method. And he would just give me the ideas. I would work at home, and he would give me all these class definitions, and I would just write them. And I wouldn't even be dealing with the larger code. I would just follow. So he was thinking in a much more macro. He's obviously a brilliant guy. Thinking in a much more macro way. I remember also when we were at Condé Nast, it was the same thing. We had a system called Travelog, which was about. It was all about just your trip, but they wanted to. It was called Concierge. I'm sorry, it's called Concierge. But they wanted to create a feature called Travelog, which was basically a little Facebook for your trips. So you'd create a new trip, and you'd upload photos to the trip, and this was before Facebook. And you'd upload like descriptions about where you went. You'd like have a map. You could put points on a map. And he was designing the entire thing in Java with classes, and so he had to sit there and basically design out in his mind and on paper all the classes and what they would do. and then we would proceed to code it. And he gave me the class that would modify the images. It would change the size of the image, make a thumbnail, and etc. Store it in different places. You had to install ImageMagick and everything. So I just inherited. Anyway, we'll talk about inheritance in a minute. Anyway, so that's classes. But we're going to talk much more about them because we're going to talk about different features of the classes. But the basic thing I want to make sure you're absorbing, and if you're not, you want to look at it again and maybe review the video when I post it, is this idea of creating an object with attributes such that you can create individual class instances that have their own data, so that this myString.upper is going to get a different result than this myString2.upper. Okay. Any questions? All right. So the handout's a little different than I've been explaining it. It's a little more complex. I've got this idea of employees. And then it goes into this idea of a basic class, what a class is. So now I'm going to go into actually what's going on with these attributes. Here's the most basic class, my class, right? Where we're creating these two objects, as I mentioned before. And we're getting main myClass instance, right? MyClass doesn't do anything, but being a class, it allows you to create instances just by default. And again, when we call the constructor, right, where's the constructor? It's the name of the class with parentheses. When we call the constructor, it's going to try to call init. But if it doesn't find init, it won't call it. So it's fine with init not being there. It'll still return a good object, which means that you don't need to initialize any attributes. You could be doing it all in your methods, right? You could be setting your methods in you're setting your attributes in your methods, or have it do whatever else you want, really, whatever the hell else you want. Maybe you want to make it so that it doesn't hold on to any data at all, but that when you call a method on it, it gives you a random number, right? Or whatever you'd like. Questions? All right. So, instance attributes and instance methods. All right, so we have this idea of setter and getter methods. And I think I have a better example here. Yeah, setter and getter. You'll hear this term bandied about, setter and getter, a setter method and a getter method. The idea of a setter method is that it sets an attribute value. The idea of a getter method is that it gets the value. So let's look. Here's another example of a very simple class. What happens when we create a new instance of the class? What does it try to do? It tries to call init. Is there an init? No, but it's fine with that. Just doesn't call it, right? But we do have two instances that know that they're myClass instances. So when we say a.setVal with an integer, it's going to look in myClass. It's going to look in myClass because it knows it's a myClass. It just knows. The object has been given the identity of a myClass. So we say setVal10. How many arguments are going up to setVal? Here's your quiz. How many arguments?
2.
2?
Self and
But I only see 1. That's there's. I'm sorry. There's an implicit first argument when you call a method on an object, and that's self. Right? That's why in setVal you see 2. I don't want you to get confused with that. The implicit first argument is always the object. So A, which was a myClass object, is actually now self. Self is A. And the second time when we call B setVal, self is B. Okay, so then it takes self, creates or recreates an attribute in self, and gives it the value val, which was whatever we passed, the integer. Then we say print A get val, we get back 10. We say print B get val, we get back 100. Let's look at get val. How many arguments have we been passed to get val? Don't answer. How many arguments have we been passed to get val? 1 argument, right? The implicit first argument, A, gets passed, and that's what gets assigned to self. Return self.value, it gets us back what we set originally. That's it. The setter value simply sets an attribute, and the getter value gets that attribute. So when we return self.value, we're returning 10 or 100, depending on how we set it. So no init going on here. We're just setting and getting values. And again, when you look at other documentation, other discussions, you'll hear about this term setter value, getter value. And that simply does probably a little more complex than what we're seeing here, but it's simply setting or getting attributes in the object.
But just the fact that we have the setters and getters signifies that, you know, the variables are private inside the object.
Well, it's very interesting you should mention that, because I'm about to show you why they're not private. Yes, it does imply that they're private. Saying self.value and return self.value, and the fact that we have setter and getter, does imply, or it seems to imply, that the attributes are private. And I'm glad you mentioned that, because I was about to show you why they're not. Why they're not. Why they're not. And this is what's kind of freaky about it, and might seem to violate an important aspect of object-oriented programming that I wanted to mention to you. Do you remember that we have already talked about an aspect of object-oriented programming? I can tell you, I guess this won't show up if I write it on the board for our friends at home. There are 3 aspects of object-oriented programming. 3 pillars. 3 pillars of object-oriented programming. Can you imagine how dopey my videos would be if I had like access to animation and stuff? 3 pillars of object. What are they? Well, we've talked about the second pillar, which is polymorphism. I'm sorry, the third pillar, polymorphism. We've talked about that. Remember polymorphism? It's the idea that you can call different methods on different same name methods on different objects and getting different results. We'll talk about that later. What we want to talk about right now is encapsulation. Encapsulation means that the data is preserved. The data is preserved behind the interface. The data is preserved behind the interface. Let's look at the getter and setter. How is self.value changed? It's changed using setVal. Now, if we wanted to change my class so that it only allows integers to be stored in the object, only integers, let's just say, must be an integer. What's to keep us from saying setVal hello?
We don't have any try catch.
Yeah, nothing stops us at this point. But if we wanted to stop them, we could, right? Because they could say setVal hello, but up in setVal, we would check to see if it's an integer. We would use a try except. We would try to integerize it. And if it won't integerize, we're not going to allow it. We'll return none. We'll say self.val equals none. Right? We would change the code ourselves. It would be quite easy, right? We would simply say try int val. Or you could just say, let's just put it right in here. We'd say try self-val equals int val, right? Except, what is it, a value error? Except value error. Self.value equals none. Screw you.
I don't think it's a value error with
Type
the
error.
parentheses.
It's a type error? Oh, right, without parentheses. Yeah.
Why wouldn't that be a type error?
I don't know. Let's check. See how easy it is? It's a value error. Why wouldn't it be? Because we put the wrong value in. That's why. It wasn't looking for, it's not checking the type. It's looking at the value and saying you got the wrong value. Because you can put a string that is 5, remember, to initialize it, so that'll work.
While we're on the topic,
Yeah.
I noticed something in my code. I forgot to actually even put a type of error to check for.
Mm-hmm.
So I just typed except colon.
Yeah.
And it took it.
Yeah,
right?
it works.
But it wouldn't check obviously for what I'm trying to check for.
Right.
So it just does a global.
So it's a
Yeah.
error.
Any sort of exception,
So it's-
it'll
Error.
catch. So the question is, if I say except, it's still going to work. It's still going to work if I say except. And that's fine. It will catch any exception. The reason it's not a good idea is because if some other error crops up, it'll catch that as well, and you won't, right? You'll miss it. Ed, were you going to say something? Okay. So it's bad practice.
No,
Yeah.
but I think Arthur was saying that he did put the name of the exception, which was a base class of.
Oh, you had an exception name?
No. This is what I actually.
Oh, you.
Yeah, nothing. Okay. It's true. You could put the base class. Yeah, we'll talk about that later. Okay.
If you want to accept two types of errors, do you just do comma? Or
Yes.
You could do two exceptions.
Yeah, if you want to
One
catch
after
two,
another.
yeah, two type of exceptions, you could say value error, comma, type error. Yeah, that would work. I mean, that works that way. You can also chain them. You could say if it's a value error, do this.
Yeah.
If it's a type error, yeah, you know that. Okay. All right, so this is now, the setter value is now maintaining the integrity of the integer, of the attribute. This is now assuming that we want our attribute to always be an integer, must always be an integer. It's going to lop off any fractional values or reject any strings that are passed up that aren't integers. Great, it's doing what we want. This is the point of a setter value. That it's gonna basically do whatever prep work is necessary. It's gonna make sure that the value is correct. In other words, just gonna keep everything straight and not let us screw everything up. Now let me show you how we can screw it up. This is how we do it. We refer to the attribute directly. Okay, this works too. You see I'm changing a.value equals hello. Now, a.value and self.value are the same thing, right? When we say a.setVal, we have the implicit first argument, which is self. It just means that a gets copied to self. The whole point, yeah, breaks. Now, the encapsulation is embodied in the setVal check, right? Encapsulation says we're going to maintain all of the workings of the code behind an interface. The interface is setVal. And setVal interface is, give me a value and I'll work it through and make sure. I used to use a metaphor of like a file clerk. You say to the file clerk, here, put this in the right file, and he takes it and he makes sure that the file's all maintained in the right order, right? If he lets you go and rifle through the files, you're going to screw everything up and he won't find it the next time. Same sort of idea, metaphorically speaking. We're making sure that our value is going to be an integer. We check it. We use a setter method. That's encapsulation. Behind the proper interface, we can set the value. But here, in a.value, totally breaking encapsulation. That's actually a quiz answer. What facet of object-oriented programming is being broken in this case? And the reason it's being broken? Well, the whole purpose of the setter value has now been completely subverted when we just set it to a string, right? It's totally running around the setVal method, which had a very important purpose. And if we had changed setVal to make sure it's an integer, because we know that later on we're going to, let's say, add it numerically to something else, and it must be an integer to work, this a.value equals hello is going to just gum up the works. We're going to get an error that we weren't expecting, and the user will see it. Right?
So would you know if it's fixed in version 3?
Oh, I doubt it. I really doubt it's fixed. You're asking if it's fixed. The question is it broken right now? And a lot of people would say, yeah, it's totally screwed up.
I mean, this and the other thing you dropped on us.
Oh, the thing about labels?
Yeah, when you can assign a keyword.
Right. Well, yeah, this does kind of seem broken. And I'm really curious, but the reason I really doubt it is because, first off, and the question is this, sorry for the folks at home, the question is this breaking of encapsulation, is that fixed such that it won't allow it, right? First reason, the spirit of a scripting language is that there should not be, that everything is done voluntarily, right? So the code doesn't force you to do anything the way it does, let's say, with Java. The spirit of a scripting language is it's rapid development, so we're not putting in a bunch of compiler blocks, right? Second reason, I guess for the same reason they don't do these checks, it would take a lot of extra compiler time to make these kinds of checks, perhaps. And what's the other reason? It would create a kind of a, I don't know, I think it would create a kind of a special use case thing. There's a certain symmetry, there's a certain consistency here. that the idea of an object changing up here but not being able to be changed down here, that's like a special case, right? If you're in the code, you can change it. If you're outside the code, you can't change it. It's the same object, right? Objects being passed by reference, right? You can change the attribute of the object. Why is there a special case out in the main body of the code? You can't change the object. You should be allowed to do it because it's consistent now, right? Otherwise, we get this special case. It can't happen here. It just seems to be beyond the spirit of violating the spirit of Python. It's my best way to explain it. But we really now we got to get out 3, right? Got to get out 3 and check this stuff out. All right, so that's your quiz question. What facet of object-oriented programming is being broken when we set an object's attribute directly in the code? That is in the main body of the code, the calling code, what we call the calling code. And the answer is encapsulation. And the reason is for what I'm illustrating here. This set val does this very specific check that's being run around, basically it's being subverted here. Okay, questions?
But this shows the benefits and the negatives of this language compared to Java, let's say, right?
Right.
Everybody complains how much you have to write in Java, how much code.
Right.
But there, this won't be allowed. And
Right.
vice versa.
Exactly, yeah. It illustrates the pluses and minuses of each language between Java and Python, absolutely. The fact that Java checks means, but see, and it goes hand in hand with Java being compiled as well, because all these checks will be done during compile. Java requires that you jump through these hoops, and for good reason, right? You could easily tie yourself up into knots with all this freedom. On the other hand, yeah, it requires that you do a lot of forethinking. You don't have the flexibility to make a change like this, which...
Yeah, because the first few homeworks, I was writing, string, and I was all writing as, str, and
right.
without even realizing.
I know. It's crazy. It is crazy. It is. It's true. Maybe they fixed that. You want to check it out? See if they fixed that?
Yeah, I'll try.
All right. Okay. So let's see. The next thing I want to show you, let's see if there's something else I need to say. So that's encapsulation. And here's my integer, right? I'm glad I didn't make it into a homework. Here's my integer doing exactly what we said before. All right. And then here, increment val, right, requires that self.val be an integer. It must be an integer. That's why the setVal method is making the check. Boy, there seems to be a mistake in here, actually. It looks like it's never integerized.
No. You're fine.
It goes up as an integer. Okay, fine, right. It just can't go up as a string that's an integer.
Well,
okay. You
well,
can't give it the
but-
string 5. What?
But the way you do it, no,
It works.
I think you should say int val. I think it's
Is val
wrong.
here?
Yeah, but
Yeah.
aren't you
Because-
breaking encapsulation again in the increment val? Shouldn't you say set?
No, because we're here in our class code. Yeah, right. We know what we're doing.
No, I think you should say int self val is equal to int val.
I think it's just because it could be a float.
No, even if it's a string, then
I mean the string 9
then
with
in
quotes around it.
increment val it'll break, right?
If it's a string, yeah, but here it'll catch it there.
No. Let's say it's a string you passed like
With 9.
it
You're right.
floats 5.
You're right. I should interiorize it. You're right. But basically, if you pass it as a string 9, it's going to fail here. Is that what you mean?
No, it's not.
Right, it won't fail. Right. So you're right. Okay, I'll change the handout. Okay. Now, here's the deal. Instances have their own namespace, right? Here we're breaking encapsulation, right? Now, of course, this also means that you could design a class that encourages or puts in the documentation that the user can actually change or create attributes of the object. It could be that you'll say, create a new object and set the attribute, Joe to this, and then the class does something with that attribute. It could be that that's how you work it. I'm not saying that's the best way. Obviously, getter and setter methods seem much cleaner, but it's something you could allow. But here it is. We're creating 2 new objects of the class, and then we're setting attributes. They're both happen to be myval attributes in each individual object, right? And then they're retrievable, right? Any questions about this? It's very simple. You can create as many attributes as you like because each object is like a dictionary. It's like a little sort of dictionary, a walking dictionary. But we're breaking encapsulation. Now here's what I want to show you. And rather than show you this example, which we'll come back to, I'll go back to our old standby. I'll create a new, this has been Python. I'll say class, this class, object, pass, A equals this class, B equals this class, A.val equals 5. Only instead of doing that, I'm going to say this class dot val equals 5. And then print A dot val, print B dot val. And maybe I'll also say, I'll say class val. Let's just start with this. Now notice, I'm saying this class dot class val. Then I'm going to print A dot class val, and I'm going to get 5. I'm going to print B dot class val, and I'm going to get 5. This is something that we call class data. Now when we said A dot val, right, A dot something or self dot something, we were talking about what we call instance data or object data. That's data that's specific to the object. This is class data. As you can see, the class can have attributes as well. And the class's attributes can be also arbitrarily set by just using object.attribute syntax. So we print A.class val. Well, interestingly enough, we can print this class.class val. And we'll get 5. Yeah? But if we print A.class val, we also get 5. B.class val, we also get 5. What does that say to you? A would be like self, but we're not even, now we're just talking about the objects themselves, the class itself.
Right, I guess it first looks for instance variable, right? And if that doesn't find it.
Yeah, we'll get to that, that's true. The first thing that we learned is that the class has its own set of attributes that we can set and get. Right, but the second thing that we learned is that A and B can read the class attribute. They both have access to the class attribute. That's the first thing. Any questions about this?
Can you repeat that again? No, just that phrase.
The last thing?
Yeah.
That each instance has access to the class attributes. We set a class attribute, and A and B suddenly can see it. There's something else any question? Yeah. Something else I'll show you.
But
yeah.
You assign this class to A before you assign this class the class value equal 5.
Right, right.
So how would it goes back, I guess?
It's not so much that it goes back, it's that when we say A equals this class, we're associating A. It's a new self, an object that knows that it's a this class. So it always knows that it's a this class. So if we change this class, when we say A.class val, it's going to just refer to the class. And since it's already changed, it'll know it. So the value doesn't actually change in the attribute at all. I mean, sorry, in the object at all. It doesn't change in the object at all. It just changed in the class, but the object refers to the class. It looks up in the class. I'm showing you the guts right now. What I showed you with getVal and setVal and the whole like make an integer or all the classes that I've shown you so far, that was the practical application of classes. This is how we create them. We use an init if we want to set attributes in self. We use getter and setter methods. And you're going to be doing that as well. And for your homework, you're not going to be using class attributes at all. But we could do a further homework where you will. What I'm showing you right now are the guts. The objects can have attributes. The class can have attributes. And the objects know about the class attributes. They can refer to them.
So if you have a situation where 99% of the time an object has an attribute that the class shares, but there's a special case where it doesn't, could you overwrite it in a specific...
So glad you asked that. Because here's where it gets a little freaky. Let's say we were to, let's see, how would we do this? Well, the way we do it is this. b.classVal equals special class, what is it, instance value. Okay, same code, but what we did was set a class val instance in B. Now, a.classVal, there is no a.classVal, right? Not in the instance, right? So it doesn't find it in the instance, so it looks in the class. But B, we set it in the instance. The same name. They're not the same variable at all. They're just the same name. And it found it in the instance. So yes, that's the answer. It looks in the instance first, and then it looks in the class. This is more guts. You could set, normally you'd probably try to choose a different name. But if you ever wanted to have this, I mean, if you wanted to have an instance variable, but maybe you wanted to work this way.
I could think of some scenarios possibly.
Oh, okay, yeah, exactly. So you have kind of a default value sitting in the class.
Right. Or is there a better place to express that type of thing?
No, there's no reason you shouldn't use this. It's there for a reason. So yeah, I think it's fine. I suppose I would think a little more awkwardly, less elegantly, and I would have a init set a default value in each instance. And then if I wanted to change it later on, I would change it in some objects but not others.
Or if you had a subclass for one of the special cases.
A subclass. You mean like inheritance? Yeah, you could do that too. It's true. You do that too. This is almost kind of like inheritance. It isn't really inheritance, but in a sense, the attribute, it's more like a lookup. Remember we had that LEGB? You look up in the local scope, meaning a function scope, and it'll look it up in the enclosing scope in case it's got a nested function, then in the global scope, and then in the built-in scope, right? We've got these lookups. With an instance, it's going to look in the instance namespace. If it can't find it, it'll look in the class namespace. It's that kind of lookup. And if we were to delete b.classVal, it would go back to looking it up and finding it in 5. We could say del, I believe we could say del b.classVal. And then it would go back to finding it in the class. Of course, the class hasn't changed. It's just doing the lookup. All right, this is the guts of it. Now, one of the reasons a.classVal should work, you should realize, is the thing about ClassVal is that attributes in the class could be set directly in the class, and that happens. But the other way they can be set is making them variables of the class. So this works the exact same way. If your variable of the class is ClassVal, that's a variable inside the class. It's not a variable inside a function, and it's not a variable inside your global namespace either. It's a new type of namespace that's in the class. And this is a variable in the class, and it works the same way. This time we didn't set it in the class by name. We set it in the class by procedural code. So we say print this class.classVal, and it gives us 5, and the same functionality works. A.classVal finds it in the class, and b.classVal finds it in the instance first. Now, if you think about it, when we call a method on a object, right? We have a method object, let's say, def getVal self return self dot classVal, right? And if we were to call it down here, print getVal, print a.getVal. Do you see how this is working now, a.getVal? Remember I was saying before, you know, it finds it in the class, right? It's actually looking for it in the instance first and then finding it in the class because a.getVal is a class attribute. I'm sorry, getVal is a class attribute. We defined it in the class. The same way we did with classVal being an integer, getVal is a method. It's a function, right, of this class. So when we say a.getVal, it looks for it in the instance first, doesn't find it there, finds it in the class, and calls it. So it's the same sort of lookup that's going on. And it's the same, I mean, it's the same method calls that we've talked about before. It just makes use of that same lookup and finding it in the class. And I think that takes us to the end. Any questions? My darling students, gentlemen, fellow travelers in the world of Python. Okay, here's where we need to fake an argument for the benefit of the YouTube viewers. Pretend that we're like getting mad at each other. And ready?
Hey, you.
Huh? Hey.
Hey.
I can't say. What was your question?
I don't know.
I can't believe you asked me that. That is the most ridiculous thing I've ever heard. Oh my God. Get out of here. Every single one of you. I want you out of this room. Class dismissed.